like a blank slate today. You are super. Okay. You'll figure it out. So you are. That's exactly it. I put paper. The reason the stack is in front of you, Colin, because I knew. Do you have a doodler on your iPad? You need to download Good Notes. Can you do Good Notes? Can you get that?
Okay.
I think it might be free. Try and get that one. That's a good one. Notability and Good Notes. One of them's free. I think one of them's 99 cents. I like Good Notes. Here's what I'm going to do. I'm going to give you matrices at this point. If I say solve a matrix, this is what we have, or and solve using matrix, or those are the words that get thrown out there. Solve using a matrix, solve a matrix, so on. Let me give you an example. Here is x minus y plus z equals 0, and 2x minus 3z equals negative 1. And if anything weird pops up, you just let me know. Negative x minus y and 2z. Stole this from your book. Equals negative 1. That book that you didn't know about. Should be negative 1s in both cases. The book. See those okay? Want a question about a number or anything like that? I know it's blotchy, but hopefully you get the idea. Okay. So with this, when I say solve using a matrix or solve it, like solving means find x, y, and z. So that's the deal, is I want to find x, y, and z. So literally when I'm done, I'll tell you what x is, I'll tell you what y is, I'll tell you what z is. It's going to be great. And later on we'll do it a second method too. So I'm pretty excited about this. Matrices make this pretty nice. So what we can do is, if you want to solve this using matrices, we can go 1, negative 1, 1, and 0. And what we've done, if you remember, is we're just organizing this in a different way. I'm going to go up and put a little different color action in here. You're putting your x coefficients here, y coefficients here, z coefficients here, and numbers yonder. So far, so good. Okay. Telephones away before we have to go to the rack, and I know your classmates are not excited about that. You got to take this in. This is a one-time only. Remember I said once and done, and it's on the test, and you got to learn how to prioritize.
If we wanted to, do we have to use matrices?
So I'm gonna prescribe what I want you to use, right? So I'll be real clear about please use a matrix to solve this, or solve the system any way you want. Use a calculator to check, or things like that. I'll give you all kinds of cool hints, but that's a really good question. The next line, and do you remember I'm grabbing the x, y, z coefficients and the numbers, so that top row right there, I just wrote right there in a different matrix form. Cool. Now below the next row, I got 2x, I don't have a y, so you got to put a 0 in that spot. Negative 3, negative 1. So zeros for any missing variables. And you have to keep the order. If you choose it to be x, y, and z, your matrix, if that's your order of variables, you have to keep it that way. You have to sort them and always keep it that way throughout the whole problem. If you want to go z, y, x in that order, that's fine as long as you maintain it and remember it. So you just have to be consistent. Negative 1, 2, negative 1. Awesome. All right, so this is how we sort it into a matrix. We did row operations to solve this, and I'm going to do it, just going to write it all out up here. So are you good with the sorting it into a matrix? It's just an organizational tool. Everything good? Okay. That was just a review of the other day. Now, this is where the fun starts. Our goals, let's review where we want to do. I really, really want these to be zeros. That lower left corner, I want to make them all zeros, and we're going to use elimination, like multiply by number, add the row to it, make stuff go away. So and remember the first goal though is to get that lower left corner to be 0 first, like that's the highest priority, is make 0 happen there. Okay, I'm going to zoom in and let's rock this thing. Here goes. I'm going to do the following. To make that go to 0, I'm simply going to add row 1 to row 3. So by adding the top row 1 to row 3, just add them down. Do you kind of see what's going to happen? It's going to give me a 0. It's going to cause a result of 0. And when you're doing matrix operations, you always write the result first in the next matrix over. Like what we're doing is doing elimination like we did old school and solving systems, but we're doing it in a matrix and we're doing it repeatedly. So the results of adding row 1 to row 3 is 0. And you put it in the second row. The result has to go in the row here. Whatever that second row, you're adding rows to rows. The second of those two in your summation is where the result goes. So 0. What's negative 1 and negative 1 makes negative 2. 1 and 2 makes 3. 0 and negative 1 makes negative 1. You like that? Everything else goes back the same. Totally the same as it was. 1, negative 1, 1, 0, 2, 0, negative 3, negative 1. So it's all back the way it was. The only thing that changed was this is the result of that previous sum that I just went through. We're partway to our goal. We still have some more to do. You remember the goal is to get zeros in these corners. So now I'm going to work on a 0 where that 2 is. That's my next goal. You do just one little goal at a time is get those to be 0. So here goes. That's my next step. What do you want to do? How do you make that 0? Any cool ideas? You want to mess with row 1? Yeah. Negative 2r1 plus r2. What do you want to say now? r2 d2. I mean, you can't help it. You just can't. Oh, now that you're all here, did one of you guys borrow my phone charger? Because I loaned it to some guy in somewhere, and I don't know what class it was, and it never came back. I'm just wondering. Okay. Then it must not be y'all. That was to make 0 happen in that 2 I highlighted there, in that middle row. It's going to make a 0 out of that. So the goal is to get zeros in that lower left-hand corner and then just kind of keep rolling. I'm going to squish that up a little bit. Now, I'm only going to put the result in row 2. Remember, you're always putting the results in that second place. So I'm going to go 0 because I'm going to write and I'm really bad at remembering this stuff, so I always write it like this is going to be negative 2 when I multiply it by negative 2. This is going to be positive 2 when I multiply it by negative 2. This will be negative 2. And this is going to be 0. Then I'm going to show the addition. And this is just me being like I can't remember stuff. Terrible memory. Cool, so I'm going to add those down. This is just a pictorial version of what I'm doing. Now I'm going to go write the results so you kind of see it. Negative 2 plus 2, 0. 2 plus 0 is 2. Negative 5. Negative 1. Okay, there's my result. Just keeping an eye on that result. That's all that's changed. Everything else goes back the way it was. 1, negative 1, 1, 0, 0, negatory 2, 3, negative 1. How am I doing on my goal? Getting close. One more to go? Okay, we got to get this negative 2 out of there. Goodbye, you. Just got to get out of there. Now, we got some options. How are we going to get rid of that negative 2? What are you going to add to what? What?
To row 3.
Row 2 to row 3. Why not row 1 times negative 2 and then add it to row 3?
Because that would get rid of the 0.
If I took row 1 and added it to row 3 in some form, I would lose this 0 I worked so hard for. Don't do that. I don't want to lose that. That's so important. We wanted it. So yeah, we're going to do row 2, add it to row 3. I'm going to write the rule up here. Row 2, and I don't even have to mess with it. Row 2 plus row 3. No. That's not true. Add them together, and what do you got? That's right. But Salagazula means? No, Menchikaboolaroo. But the thingamabob that does the job? Is? There it goes. Nicely done, nicely done. Nicely done. All right, I'm putting the result down here. Oh, that's a smiley face. I got to zoom in to make that result happen. Negative 5 plus 3 is negative 2, and negative 1 is negative 2. Okay, that's two negative 2's, isn't it? Okay, I got to zoom back out. Do you like it? Are you okay with that? My result? I like to highlight the result so you know that that's the only thing that changes. The rest goes back to the way it was. 1, negatory 1, 1, 0, 0, 2, negative 5, y negative 1. We've met our goal! Dun, dun, dun. So once you've met your goal, getting zeros down here in the corner, we can rewrite it as its old-fashioned system of equations. Like, it's going to be x minus y plus z equals 0. That's our first expression. I'm just translating what's on the left to the right. So these are the same things. And now it's 2y minus 5z equals negative 1. Okay. Negative 2z equals negative 2. What do you think? You okay with? I put it back as a system again. Matrices in these systems are interchangeable, just different organizational systems. Okay. You okay with that? You want to see? Do you think I could get my x, y, and z now? Do you think I got this? Well, I got z. Let's go. Let's just go there. And this is like a. Once you have z, z's the catalyst for the whole reaction to just take place. Because once you have z, then you can get y. And once you have z and y, then you can get x. You can put it all back in. So let's go get z. Y'all okay with me just saying z is 1? You okay with that leap? Now we can put it into the others. If z is 1, so let's go in with a hot pink 1. I can make this 1. And if that's 1, let's do some mental math. We could add 5 to the other side and get 4. And divided by 2, we get 2. I'm thinking that this is now 2. Okay, if y is 2 and z is 1, I can go up here and put 2 and 1. We could get x. So x minus 2 plus 1, that would be like the same thing as x minus 1. Add 1 to the other side, I get x is 1. What do you think? Getting it to this slanted, reduced form allows us to have a catalyst z that we can then plug in elsewhere. We can get y, and then it's kind of a chain reaction, right? It's a domino effect. I can get y, then I get x. Whole thing opens up. That's why we wanted zeros in that lower left corner, so that we can do this substitution up the chain. Okay, that's Gaussian elimination-ish stuff to get what we call reduced echelon form. If I can move on from there, that's just a little review. Now I want to show you how our fancy pants calculators will take care of some of this too. That's important. All right, to the side, Clyde. Grab your calculator, because there are many a trick you'll learn on the calculator today. There's mine. If I make you do it by hand, similarly, yes. Because I'm not, if it's going to be complicated, you're going to want to use the calculator. I don't want you spending all your time on a reduced echelon form problem. I wanted to record that I took attendance. So this is also being recorded. Isn't that funny? There you go. Just in case. I need evidence that I took attendance today. Yeah, I still am, actually. It's all on there. Let's go matrix. Matrix action. So would you go under second matrix, you can edit any matrix you want, and I'm going to put in the one that we made, which was a 3 by 4. So if you can't see that that's a 3 by 4, let me write up there. 3 by 4. 3 rows, 4 columns. Okay, so there we go. 3 by 4. And then you start entre, s'il vous plaît. And negative 1, 1, 0, 2, 0, negative 3, negative 1, negative 1, negative 1, 2, negative 1. Okay, there's my matrix. Once you enter it in there, I'm going to go back to the home screen and like enter it. Oh no, get out of there. Get out. Get. See if it looks right. I always like to print it out and hit enter, check my numbers. 1, negative 1, 1, 0, 2, 0, negative 3, negative 1. If you mess up one number, your answers will be different. Everything you do will be different than mine. It only takes one slip. Then it screws up the whole thing. Cool? Calculator, Maximus, here you go. These are good. Anyone else need one? If you want to play with this, because you're going to need it. Okay. Next, this is how I'm going to tackle it. Remember I said that's reduced echelon form? Well, it's not quite. The calculator goes even a step further. So I want you to, I'll highlight on my screen. I'm going to put a big fluorescent, I don't know, what color do I haven't I used yet? Let's just go with like blue, dark blue. This thing I got right here is almost reduced echelon form. You'll see that your calculator is going to produce that with just a little bit different. And you'll know what. Ready? Go to matrix. There's some options called math options. So under matrices, there's all these math things you can do with them. You roll down, 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 you're going to get to something called REF, reduced echelon form. There's also RREF, which is row reduced echelon form. But we just want ref, not ref. Ref it. This is what happens. Since now you're familiar with your matrix and what we got, I'm going to put it down below. I want to compare what we got with what the calculator spits out as REF. Side by side.
Wait, how did you get the A?
You actually, whenever you want to call it matrix A, you got to go second matrix and you got to hit enter on the right matrix. Okay, so now I got ref A. This is what I get. The difference between what we got with our row reducing process. See the 2's that we have in our diagonals? They got rid of them. Real easy like. All they did was divide through in the second row by 2. So Kyle's looking up there going, Kyler and Kyle are looking at this middle row and they said, hey, they have a 1 in their middle row. I have a 2. Oh, they divided through everything by 2. And you can do that. And that's where theirs is. You can't. I typed it. I mean, this my calculator just does it. I didn't do anything but type it in, and it's under matrix math.
Didn't work for me.
Why does mine look different than yours?
You messed up.
So this is the deal. If you don't, if you got to retype your matrix A, and I've put mine up on the screen because I wanted you to know this is what my matrix A looks like. If you type in A, and you don't get the same thing right here as I've got, this is my matrix. Then when you do ref A, it's not going to be the same thing. Like one little error is enough to throw the whole pot out.
Error data type.
So watch your typing. Errors are easy matrices. Cool? Get typing. You got to get this one. The next thing, you guys got to look at the screen here. You got to play it out. Do you see that dividing this by 2 would produce the same thing here? That's the only difference. They divide this by -2 to get 1s here. Your calculator just gets 1s in the diagonals, and that is the easiest thing to get. Just divide by that lead number through the rest of the equation. Is it necessary? No. Doesn't make any difference. Doesn't make your solving any better. It's just what the calculator does. We'll go with it. So now, I just want you to know what we did and what the calculator did are very similar, and they serve the same purpose. Next goal. Listen carefully. Now, wind down your secondary conversation so I can show you another thing. Do you see that z is equal to 1 in the calculator output? 1z equals 1, same thing we got. If we put 1 back up here into this equation, since we pointed out it's the same as the one we've got, you're still going to get y equals 2, you're still going to get x equals 1. It does the same thing. It gets you down to that reduced form, and you can solve it. Okay, now there's one more crazy step that I want to show you. We're going to do our REF, which is the next option down under math. You go way down there. It's like option B. Here it goes. Ref matrix A. This is going to blow your mind. Wait till you see this. Hit enter. What does that mean? 1x
Since I entered some numbers in, bro.
equals 1. Oh! 1y equals 2. And 1z equals 1. It gives you like the answers. Like, it tells you x, y, and z explicitly. Isn't that weird?
That's easy.
It's your calculator doing additional row operations to make all these other numbers that weren't zeros. They made them zeros by doing the same stuff we did, the same row operation. So you can go further. You continue operations to make zeros happen in these other spots, you'll get the answers, but that's not necessary. You don't need to go that far. The basic idea is you guys know how to do it by hand. REF is you're doing reduced echelon form, and then when you're done, you're plugging in the z that you got in for the other equations, getting y, and then getting y and z into the first equation and solving for x. It's a cataclysmic event. One answer begets another. Moving on, I'm going to give you some more. That was part one of the other day, just in some cool context. Well, that's weird. Could be worse. Now to the next pace. Let's take on a new one. I'm gonna give you guys something. Remember multiplying matrices? Yes, you do. You totally remember it. Let's talk about multiplying matrices. Let me give you an example. A times B, matrix multiplication. Let's do it. Here's my A. Here's not my A. Here's my A matrix. You gotta borrow my matrix. It's gonna be negative 1, 3, 0, 1, 1, 0, negative 3, negative 1. So what we've got here is a 4 by 2 times B. So this will be our A matrix, and here's B on the side. B is going to be 5, negative 6, 2, 3. And multiply them together. That's a 2 by 2. When you multiply those two together, is it possible? Do you guys see that? Is this a possible multiplication? Do you remember what to look for? Yeah, these got to match. These match, and the result will be a 4 by 2. So when we're done, these guys got to match in the middle, and then the result, and this isn't a mystery. I want to show you today it's all good. 4 by 2 is the end result. You put in your calculator. So here's it. When we're done multiplying these two together, we are going to get a 4 row by 2 column result. So 1, 2, 3, 4. 1, 2, 3, 4. Got them. Let's do this thing. The process is you take rows times columns. Now I'm going to do some highlighting, and then I'll undo it when I'm done. I'm going to take negative 1 and 3 times 5 and 2. I'm going to turn the rows on the left sideways and multiply them by the columns on the right, and I'll do it again for the second column. So the results of that, you might recall, are going to be negative 1 times 5. I'm going to write this one out first, and then from here on out we'll just work it. Negative 1 times 5 plus, remember the other one is that 3 times 2. Okay, and we're going to write the number in there. I'm just working it out. I'm going to get rid of this calculator for a minute. Sorry about that. There it is. So that's just that first row times that first column. Check, check. Okay, we got that taken care of. Now we're going to take the first row times the second column, so -1 times -6 over here. So -1 times -6 plus the, let's see, -1 times -6, and then 3 times 3. Okay. So that's how we do each one of those. I am not going to write those out. There's no way we're going to write that out each time. We go to the next row and we do the same thing. So now moving on to the second row. Going to 0, 1 times 5 and 2, and then 0, 1 times 6, -6 and 3 in this special style. You guys watch my arithmetic because I'll likely screw it up. So 0 times 5 is 0, plus 1 times 2 is 2. And then 0 times -6 is 0, plus 1 times 3 is 3. That's what I'm getting for those. Next row. So I go 1 times 5 is 5, plus 2 times 0 is 0, so it's 5. And then 1 times 6, -6 is -6 plus 0. And finally, the last row times all the columns. -3 times 5 is -15. Take away 2 is -17. And then -3 times -6 is +18. Take away 3, which is 15. That's the process. You have to be able to do that by hand. Yesterday I said you'll get 1 or 2 multiplication by hand problems. The rest of the time we do it with a calculator. The first one is 15 up there, so I don't need that number anymore. So that's 15, and -5 plus 6 is 1. So the other one's 1. Right? Does that sound good? Okay. That's my product. You can do it on the calculator, of course, but I want to do something fun with the calculator. So I'm going to move this over, make it small, and squish it. Get over here. Scoot. Scooch. Calculator back up. Let's talk about multiplying, because it's more than just meets the eye. More than meets the eye. That's like a great slogan. Does that describe you? Are you like more than meets the eye? Of course you are. You all are much more than what we think. We don't know you as well as we should, right? Okay, there's my matrix A. And I'm going to do my matrix B that goes with it. Número 2. And that's a 2 by 2. Got it. And that's 5, -6, 2, 3. Okay. Hopefully I didn't screw anything up. I always like to double check. I go print them. So I go second quit. Clear my screens. I'm going to look at my A just to make sure it's all good. And enter. -1301110. Yep, looks good. And look at my B. 5, -6, 2, 3. Looks good. If you want to multiply them, A times B, you go A. Stick it next to B. You can put the multiplication symbol or not. It doesn't matter. And it works either way. So A times B, 115, 2, 3, 5, -6. Same stuff we got. Beautiful. So now, that worked. What if, for some reason, I had this epiphany. I said, oh man, I'm going to multiply B times A. I'm going to do this. What if I decided to go my 5, -6, 2, 3 matrix, and I multiply it by my, that one, -1, 3, 0, 1, 1, 0, -3, -1. The question is matrix multiplication what we call commutative? Can you go both ways? Take my row here times my column here. So that means take -5, let's see here, or 5 times -1 plus -6 times, uh-oh. I don't have enough numbers. Like, if I take the 2 numbers in my row on the left and line it up with the column on the right, I don't have enough numbers. They don't match up. Because this is a 2 by 2 getting matched with a 4 by 2. If these guys don't line up, if they don't match, then you have a problem. It's not going to work. Not even vanilla ice can solve that problem. Because you know what he says? If you have a problem, yo, I'll solve it. Get out the mic while the DJ revolves it. That's what I'm saying. But he can't do it. Chuck Norris could solve this one, but not vanilla ice. Let's do this. Moving on. And guess what your calculator says? B times A. Guess what it says?
Error.
Error? What's error have to do with it?
There has to do with everything.
Dimension mismatch. That's not an error.
Wait, let me see.
That's catastrophic. That's like apocalyptic. That's another good word. I like using vocabulary today. Let's do this. Moving on. That's the matrix multiplication for you. So I tell you what. Now, Sarah, I need to ask you. I need to poll you a question.
Okay.
Is this really rough so far?
So the first part was kind of confusing, but I got it.
Okay. So you're starting to think that maybe this is okay. You do too. Now knock it off. All right, back to the next one. So let's play again. I want to talk a little bit more about the solving thing with your calculator and maybe get some ideas about it. So here's 2 more examples. So more solving.
Do you want to start these down?
Yeah, these are all really important for different reasons. So solving systems with matrices, everything's important. It's all important. Solving cis matrices. What happens right now is we're gonna get infinite solutions and no solutions. You've seen that before, right? You've done systems. You know this is a thing. This happens. Should I do full screen? I want to go full screen. Can I do that? It's not giving me like a full screen option. Yeah. Oh well. Can I make it bigger? It's as big as it's gonna get, y'all. Oh, there it is. I knew it happened. So solving cis matrices. Here's an example. Here's what you could get. You could have a matrix system like this. X plus 2y is 4. And 3x plus 4y equals 5. And 2x plus 3y equals 4. Okay? And we go to a matrix, and y'all put in the following: 1, 2, 4, 3, 4, 5, 2, 3, 4. Like that. Right? And then you pull out your calculator. I'm going to go extra fast with this one because you don't need much thinking. And because you're thinking, I'm on my homework, how am I going to do this? It's going to be awesome. You go to matrix, you go to the tricks, you enter it, 3 by 3, and you go 1, 2, 4, 3, 4, 5, 2, 3, 4, bingo. And you go, Mr. Seeley, didn't you say that I could just ref it and get this answer? And it's okay, yeah. That does all that work that we do by hand. That matrix A, if I go in and I ref it, it will do wonderful things for us. Watch this. I can't get to ref fast on mine. It's such a,
Is it
oh, this is so slow.
I want ref and ref.
I want to go ref first.
Oh.
Don't overdo it. That's an extra R. Now that's all decimally, but you can frack it. Look. I gotta find out what that means, but it makes it look better. So if you hit this frac button, it apparently makes it look nicer. So you do that. Got him? Does that look good? What does it mean? Let's translate it. That's what my calculator spits out, but it doesn't help me much for one particular reason. So if I ref this matrix, if I call this matrix A, if I ref A, this is what I got. I got 1, 4 turds, and 5. I love it, isn't it? That Bostonian accent is just one of my favorites. Because you go in there like, okay. Oh yes, I heard you the first time. When I'm sitting over there listening to all your conversation, I always like to, aren't I terrible? I don't know why I hear things I don't need to hear, and I don't hear the things I'm supposed to hear. It just happens. Here it is. The ref A says, according to this calculation, right here, this is the problem that ice cannot handle. Right there at the bottom of my matrix, do you know what that says? That says 0y equals 1. In other words, they're saying 0 equals 1. Well, that's a hullabaloo if I've ever heard. That doesn't make any sense. So we say,
There's no real answer.
it's not okay. It's not real. That apostrophe mean it's not. It's not.
So if you did R on the first, would you overlook that?
Ooh, okay. So would I overlook? Let's do it. So I know you really, really, really wanted to. So let's go to ref. Just so you can see what happens. I mean, it's worth checking into. Oh, this calculator goes so slow when you're trying to go up and down a list. Ah, no. Bam.
What the?
F.
What the? Ref?
Look what that puts in there. Hey, it's kind of the same thing. It still says y equals, or 0 equals 1. Says, hey, look, it also says 1x equals 0. 1x. Hey, that's good. But the big deal is the very bottom one is saying an illegal thing. Okay, keep an eye out for that. So look for that no soul scenario. This is the no soul dealio. Let's do one that has infinite soul. Much, much soul. Here we go. Infinite soul. And how we do now? Oh, we got time. This is going to be good. You guys are going to have time to work. Okay, so we got x plus z equals 2. 2x plus y plus z equals 5. Okay, new one. It's one of them newfangled things. Now we could do it by hand, but we're not. We're going to go Juan. Now, I'm missing variables. You got to get organized. There's an x, y, and a z. You got to have a spot for all of them. So you got to sit down and go, all right, this is going to be x'ers, this is going to be y's, z's are going to go here, and numbers are going to go here. This is, by the way, you got to remember what this is called. This is called an augmented matrix. Because it's like an auger and it digs stuff. No, actually what it means is you took a matrix, and augment means extend it to hold more information. So the x, y, and z, we'll show you later another version of a matrix that isn't augmented. And what it does is it doesn't include, so glad you asked this, the 2 and the 5 in the matrix, but it still gets there. So by including 2 and 5, we are augmenting it. So if you guys go to get augmented surgery, what does that do? It adds stuff to you. So if you go and augment yourself for lots of money, I don't recommend it. It means you... Oh, you plastic surgery. Okay, that's what you got. Yeah. Sometimes they call it augmentation. Skin augmentations. If it's for a good medical purpose, great. but you're awesome the way you is.
Have you seen the video of like fake Barbie, real life Barbie and like real life Ken? Oh my gosh.
Oh, no.
So weird. It's scary.
Oh, I don't know if I want to watch it.
It's like really
There's
scary.
like
We
a
watched
TV
it in
show
mass
on, like,
media and it was not.
Oh my gosh, it's scary. I don't know. It's weird.
Shouldn't we do this one by hand? Don't you want to just once? Oh, okay. Well, let's just. Shall we? Do you guys want to do this one by hand? Because it's short and sweet.
Sure.
Okay, good call. So here goes. -2 times row 1. Now, if you want to do it with the calculator, that's fine, but I'm doing it plus row 2. It's short and sweet, so we're going to get at it. And that means if I multiply -2 here, -2 makes 0 here, -2 here, and -4 here. You see what I'm saying up there? You see that I'm going to do a row operation. I'm going to add that to the second row, put the result down there in the lower row. And so I'm going to get 0, 1. -2 plus 1 is -1. -4 plus 5 is +1. Put everything back the way it was. Okay. If you guys use your anyone use your calculator by any chance? It'd be fun to compare. You get the same thing. This time, this is exactly what your calculator will spit out, because the calculator just does row reduce until it gets ones in the diagonals, and that's what it gets. It's pretty neat. So we're actually doing the same work as the calculator today. What this translates to is x plus 0y plus 1z is 2. 0x plus 1y minus z is 1. Notice I don't have what z equals this time.
Why?
No, z. I don't have what z equals. Or what y equals. But, wait, what? So without knowing what z is, so do you want to take a peek at that? That's just all inclusive. I did one row operation. I got it so that there's zeros in the corner. And I rewrote it in the equation form, and the thing is, it used to work if I had what z equaled, and then I could plug it in and get y, and then plug it in and get x. That's why we like that nice diagonal, so that we can plug one into the next and work your way back. Well, now what do we do? So we got two options here. Maddie, what do you got? And then Colin, what do you got?
Before that,
Yeah.
2 rows, you're only going to want 1 0 in the bottom line.
So if you continue to get zeros in there, do you want to keep going?
No, we don't have to.
Check out. Did anyone try it on the calculator? If you didn't, what did it give you? Oh, so it divided through by a half? That's really funny. 0.5, 0.5. That's kind of fun. Hang on. Oh, your calculator's so small. I like it.
Y equals 1. X equals 2. I've just done this all mentally.
Uh-huh.
Yeah.
I think it works out being the same.
Sarah about to get dropped.
That's kind of cool.
Sarah doesn't want
Yeah,
to
it does a little more
do
raw
it.
operations. It'd be kind of fun to figure out why it went further. So in this event, this is what I want to write to you. By the way, it's not a big deal.
Oh, right.
Here is the end result of interest to all of us. You guys can write in what x is, what y is, and what z is. But the problem is we actually don't have values for it. It has infinite solutions because, watch this. X, see if you can figure out where I get this from. I'm going to say x is 2 minus z. Makes sense, right? Because if I've got x plus z equals 2, then x is 2 minus z. The thing is, again, I don't know z, but if I did, I'd be good to go. Uh-oh. I just ran out of power. I told you I needed my charger. No. Does anyone have a phone charger with them by chance? Mine was removed.
Didn't you loan it too? I'll get it back for you soon.
Well, thank you. It was yesterday, and the person asked nicely, and then they took it with them and plugged it in somewhere, and then I never got it back.
They just played you soon.
No, that just happens.
You can use mine, Mr.
You're on,
Sealy.
You're a
You
nice
got
guy. You're a
played.
stand-up
It's
kid.
probably
That's what I do with our chocolate.
And then he-
Steal it.
It's okay.
We
Things
gotta teach
happen.
them a lesson they'll never forget.
Can I borrow yours? Okay, while that's happening,
Oh, that's
let's finish this off so that I can get the darn thing finished. Well,
It's
that's-
gonna be
oh,
so
thank you,
confusing.
man.
We're not.
You guys wrote it down, so alright, well, we just wrote x was 2 minus z.
Yes.
Okay. Would you, if you solved for y, what would it be? Y would it be,
1 plus C.
just look at what on the sheet there, if you translate it. But, okay, that's actually the reasonable solution. You know what z is going to be? Z is just z. This is actually what we call infinite solutions.
Wait, but I like con answers. How'd I do that?
Infinite solutions. What's cool about this is that given that z, oh Colin, I'm coming to you next. If I had z, could you find y?
Yeah.
If I had z, could you find x? So you just write an expression that's ready and waiting for you to say, if you handed me z, I could give you the solutions. This is more common than you might think, because let's say in a situation that's in computation mode, if you're using a computer, and all computers use matrices for some calculation, they really do. If this situation is like saying waiting for someone to enter a key, like on a computer you have prompts, or it's waiting for an input, all the things you type into a computer go into an open input, and then there's a computation that takes place as a result of that input. So if Jordan says to her computer, I want you to enter 5, computer, and tell me what x and y are, that's something it can handle. You can put in 5 and it'll instantly give you x and y. Most computations are open like this, where it's just waiting for an input from your keyboard so that it can calculate the rest of it. Now this is a simplified matrix and kind of open-ended, but the idea is infinite solutions just means I need more information. I just need I need an x, I need a y, or I need both. We'll let this charge for a few minutes and see if I can get this back on board. In the meantime, Colin wants to tell us something cool. Colin, give me some info. You can't get to z. You keep going. If you want to try it, you're welcome to. It won't. It'll end up in a circle. You have a cycle. Here's do you remember the old rule that a system of equations, you can only solve for your number of variables if you have the same number of equations? I have 3 variables and 2 equations. Can't get the solution. It's not that it doesn't exist. It's just that there's infinite possibilities. I just need to know z. So you have to have a system that is solvable must have the same number of equations as variables if in fact it can be solved. And not all of those can be solved. It's just we're missing square one to solve this one, and it's infinite. But that's a cool scenario. I love infinite. So let's get back to some other things. Sarah, you're going to ask something. What were you going to ask?
No, it's fine. I think I answered it.
So we're in a situation now where we got a calculator thing. So that's it. That's the intro today. I'm going to hit pause on this thing, and